Okay, class, we're going to have 4 videos here talking about how important triangles are and 4 important things we have to know about triangles. As you'll see in the last video, actually, triangles are really important because with a triangle, we can build any other shape besides curvy things like circles. So a triangle, again, just to remind you from way back in kindergarten, a triangle is any shape that has 3, you're probably thinking sides, which is true, but if you think about the word triangle, what that means is 3 angles, right? Tri means 3, like a tricycle has 3 wheels, a triangle has 3 angles. And yes, in fact, it does also have 3 sides. So I'm going to go ahead and draw a triangle with this ruler and protractor just so you can see what a triangle looks like. I'm going to draw 3 different kinds of triangles. One triangle I'm going to draw has a 90-degree angle, right? In fact, I can make sure of that by using my protractor. If I put this right here, and I make it go up to exactly a 90, and this is called a right triangle. We call it a right triangle because it has one of the angles is 90 degrees, which is a right angle. Okay, so this is called a right triangle. Okay, I'm going to mark the 3 angles again. You can see here, as a triangle, it has 3 angles. 1, angle 2, which in this case is the right angle, and angle 3. I want to mark all 3 different, just because that's generally how you'll see it starting in high school, really. Is the 3 angles are different. One of them is 90. Now, we also give these angles names. So if I label the vertices, the corner points, if I label them A, B, and C, then I can talk about these angles. This angle here would be angle A. This angle would be angle B, and this angle would be angle C. Right? And I'd write that like this. Angle A, angle B, angle C. All right, now there's another way I could write those angles. So I could say angle A, or if I want to be very specific, I could say exactly what angle that angle A is. It's the ones that connect, right, angles, this point C goes up to point A and back down to point B. So I could call that angle CAB. Right? That angle is the thing that's between C and A and AB. And it's between side CA and side AB. So I could call it CAB. I could also go backwards. I could call this angle, I could call it BAC. It's the same thing. Right? I also have angle B, which again, if I wanted to say what angle B was, be more specific, I could say that connects C with B with A. Right? So that's between CBA. So that's angle CBA. Or if I want to say it backwards, between ABC. And then the last one is if I want to say angle C, that goes between A, C, and B. If I want to say it backwards, it goes between B, C, and A. And I guess the last couple things you might see is if I want to write the side lengths of this, if I want to talk about this entire side, I would connect these 2 dots, A and C. So I could call it AC or CA, doesn't matter. And we put a line above it because that means we're talking about the line segment. So this side length is the side AC or CA, depending on how you look at it. This one would be, I'm going to call AB, and this one is BC or CB, right? All right, so there's that triangle. This is a right triangle, and this is how we describe the angles, how we mark them, how we write their names, angle A or angle CAB, and how we write the side lengths. So one thing I can remember is sides always have 2 letters in it because they connect 2 points, and angles always either have 1 angle, 1 letter in it, because it's only one thing, or 3 because it connects 3 points. So angles always have either 1 letter or 3 letters, and sides always have 2 letters. Again, this square means 90 degrees, which is a right angle. Okay, let's draw another couple triangles. I'm going to draw a triangle. I'm going to draw a triangle. It's going to look something like this. Okay, that's a triangle. This is a triangle. It has 3 sides and 3 angles. And if I use my protractor, I can actually see what the angles are. This angle here is, let's see, that looks like about 71, right? 71 degrees right here. And this angle up here, if I measure this one, that looks like it's about 54. And if I measure this one down here, that looks like it is about 55. 55. I'm going to mark them all differently. Okay. You'll notice that all 3 of these angles are less than 90 degrees. And if an angle is less than 90, we call it acute. So this is called an acute triangle. All 3 angles are acute. And I'll draw one last triangle. This one's going to be a really big triangle. Let's see how I want to do this. Okay, so here's my last triangle. Has 3 sides, 3 angles. And you'll notice on this one, if I measure my angles real quickly, this one looks like that's an angle of about 20 or 19. I don't know. We'll put 19. This angle over here is measures about, oh, it's hard to go up. This one doesn't go all the way. About 34. And this big one right here is going to be an angle of about, 52. We'll say 51. Let's see. That doesn't add up. I'm going to cheat. I'm going to say it's 57. Boy, it's hard to line it up there. No, it's definitely not 57. Yeah, we'll say it's 51. Okay, I'll have to fudge things up a little bit as I get through here. That's okay. One of those I measured wrong. Let me just double check this real quick. Because you'll see why in a second. That looks like, yeah, it looks like about 19. It's got to be off. I'll do that straight up this way. It's more like 31. Okay. I'm going to fudge them a little tiny bit there. Okay, anyway, here we go. So this triangle, its largest angle, you'll notice, is bigger than 90 degrees. It's, oh, that's what I'm doing. I put 50, it's not 50. Mr. Baker, see, Mr. Baker makes bloopers too, right? This is not 50, this is 130. How silly. Can't I read it? Can't I read it? Okay. There we go, 130. There we go. That's going to work. So now it's 130. So it's bigger than 90, which means that this is an obtuse angle, which makes this an obtuse triangle. There we go. Now, here's my thing. I'm going to cut out my triangles here real quick. And so we got a right triangle, which has 3 sides and 3 angles. One of the angles is 90 degrees. Okay. And then there's all sorts of really cool things about right triangles, which you'll learn about in 8th grade especially, is when you start learning about the really cool things that are built around right triangles. There's an entire branch of mathematics called trigonometry. You can hear that tri, right? Trigonometry, that are built around right triangles. And that's an entire course you can take in high school. You can take a course all about triangles, basically. So they're important to mathematics. All right, I'm now counting out the acute triangle. And while I'm doing this, I'm going to give you a couple more vocab words just so you can know. If a triangle all has the same lengths, right? All 3 lengths are the same. All 3 sides are the same length. We call it equilateral. So equal means equal, right? Lateral means side. So equilateral literally means an equal-sided triangle. And all 3 angles, by the way, of an equilateral triangle are also the same. All right. A triangle that has not 3 sides that are equal, but only 2 sides that are equal, we call that an isosceles triangle. So iso means the same. Isosceles triangle. They're the same. And then if it doesn't have any sides that are the same length, we call it a scalene triangle. Anyway, here are my three triangles. I've got my right triangle, I've got my acute triangle, and I've got my obtuse triangle. What I'm going to do now is I'm going to tear off my corners. All right, I'm going to tear off the corner of my right triangle, that corner, and this corner, remember the 90 degrees, and this last little corner. And when I put them together, something very interesting happens. Okay? They make a straight line. You see that? They match up exactly along a straight line. And if I do that for my acute triangle, okay, it works for my 90-degree triangle, my right triangle. Let's try for my acute triangle now. I'm going to tear off this corner, and this corner, and this corner. You'll notice once again, they make exactly a straight line. You put them together. Interesting. Okay, let's see if it works. We know it works for the right angle. It worked for the acute triangle. Let's see if it works for this giant obtuse angle. If there's one I won't work for, it's got to be this one. Let's see. Okay, that'll work. So I put that angle along with this angle, along with this angle. And sure enough, guys, you can see this. Sure enough, it makes exactly a straight line. Look at that. So this is a theorem. It's called, actually I don't know what it's called, but it states that the three interior angles, the three angles inside of a triangle, add up, when you put them together, they add up to a straight line, which is 180 degrees. So for every single triangle you'll ever find, every single triangle you'll ever find, unless you go into advanced college math, every triangle has 180 degrees. All right? All triangles. Interior angles, that just means inside angles, add up to 180 degrees. Okay? All interior angles add up to 180 degrees. Every single triangle. It can be obtuse, it can be acute, it can be right, it can be scalene, equilateral, isosceles, any kind of triangle. They're always going to add up to 180 degrees. That's just what happens. So we saw the demonstration, and now you can solve some problems. I'll put some problems below. If I give you two angles, you people tell me the third angle, because if I have a triangle with one angle is, let's see, angle A, if I can abbreviate that, right? Angle A equals 100 degrees, angle B equals 60 degrees, and I want to know what angle C is. You could write this in an equation, right? You know that all three have to add up to 180. So 100 plus 60 plus angle C equals 180. Now you can subtract 160 from both sides, and you get angle C equals 20 degrees, right? So any two angles, you can find the third one just by subtracting those other two from 180. See you in the next video where we'll talk about the three sides of a triangle and how they relate.